In this video, you are going to learn about adding and subtracting rational expressions. So as long as we understand what is happening with rational numbers or fractions when we add and subtract, that can help us add and subtract rational expressions. We can apply those same concepts there. So we know when we're adding or subtracting fractions, we need to get a common denominator. So you can fill that blank in with common denominator. We need the bottom number to be the same in both of our fractions. Denominator. I just added an extra page by accident. There we go. Common denominator. So for example, if I had, let's say 1/6, and I'm adding to that 5/9, right now I don't have a common denominator. I have a 6 and a 9. They're not the same number. But what we do is we take a look at that 6. That 6 really can be broken into factors of 2 times 3. And the 9 can be broken down into factors of 3 times 3. So I'm breaking this down into the prime factorization, and then I look at what they have in common. So this has a factor of 3, as does this one. So 3 would be one of the factors that I'm going to use in my common denominator. I also have, with the 6, a factor of 2, but I don't have a 2 in the factor of 9. So I need to include that as part of my prime factorization of the common denominator. And the only other factor I have not used up yet is this second factor of 3, which means I'm timesing by another 3 here. So if I times those 3 factors together, the 3 times the 2 times the 3, that gives me a number of 18. And that is our common denominator. So looking at the 6 was a 2 times a 3. I need to multiply by another factor of 3 to make it into the 18, but to get an equivalent fraction, that means I also have to multiply the top of that fraction by 3. So that 1/6 is going to become 3/18. So 1/6 is equivalent to 3/18. Now the 5/9, if I look at my factors with 5/9, the 9ths had factors of 3 times 3. I need an extra times 2 to turn that into an 18. That was the extra factor that was missing. So I'm going to times the 9 by a 2. Now this might seem a lot more complicated than the process you're used to thinking of, but I'm going back to our roots here. What the process was right at the beginning when we first learned how to do this, because that's going to help us with our rational expressions. So 5 times 2 is our 10, and 9 times 2 is 18. So 5/9 is equivalent to 10/18. Now that our denominators are the same, we can just add those numerators together. This is really just saying I have 3/18, and I'm adding 10 more 18ths, so altogether we have 13 of these 18ths. So there's our answer for adding 1/6 to 5/9. So following along here, question 1 says rational numbers. So we're really comparing rational numbers, and then I've got a rational expression that's very similar beside it, but with our x's or our variables in it. All right, first example is fairly easy. Common denominator already. The rule is once your denominators are the same, you just add the tops or subtract the tops. In this case, it's an adding question, so 2 plus 3 is a 5, and the denominator stays the same. 2/7 plus 3/7 is 5/7. So if we follow along with that concept over here, I've got 2 of the x's, 2 over x, plus 3 out of x. The rule is you add those numerators together, the denominator stays the same. So 2 plus 3 is 5, and the denominator stays in x. So rational expression, we've just added our first set of rational expressions together. Question 2, we don't have a common denominator here. 8 is really 4 times 2. That means that I could take this 4 and times it by 2 to get that common denominator of 8. But again, we've got to times both the top and the bottom by 2. I don't know, maybe I'll actually do that on another line because that's difficult to read there. So our 1/4 to get the 1/4 to be an eighth, we're going to take that 1/4, we're going to times by 2 to make that an 8, but then we also have to times the top by 2 to keep it an equivalent fraction. And then we're adding 3/8 to that. So that 1/4 is the same as 2/8 plus 3/8. So if I have 2/8 and I add 3/8, altogether I have 5/8 for that question. All right, now if I look at the side-by-side example, here I have a factor of b on my first expression, and on the bottom I have 2 times b for my second rational expression. So I know that I could take that first equation, or that first fraction, and I can multiply the bottom by a 2 and make that into a 2b, which then means I have to multiply the top by 2 as well to keep it equivalent. So we end up with 2a over 2b, and we're adding 3a over 2b. So my denominators are the same, they're both 2b's. The rule is you just add the numerators. So if I have 2a's and I add 3a's, altogether that's 5a's over the 2b. The denominator stays the same. All right, try the next pair and see if you can work through that. Put the video on pause, and then you can check. All right, common denominator here would be a 6. I would need to multiply that second fraction by a 2 on the top and the bottom. So that minus 4/3, I'm going to times the 3 by a 2 to make that into a 6, but I also have to times the 4 by a 2 to keep it an equivalent fraction. So 5/6 take away, that turns into 8/6. The rule is subtract your numerators, so 5 take away 8 would be -3 out of 6. Now that can actually go to lowest terms. That's going to equal -1/2. I'm just really dividing this time, top and bottom, by 3 to make that in lowest terms. All right, let's see what we can do with the one beside now. I noticed that they both have y's already common. This has a 4 and this is only a 2. If I were to multiply the second fraction by 2, top and bottom, that would turn that denominator into a 4y, which is the same as the first fraction's denominator. So we have 7 over 4y, take away 5 times 2 is 10, and then 2y times 2 is our 4y. So now we've got common denominators. 7 take away 10 would equal -3 over 4y. Now there's nothing in this particular example that I can reduce, but sometimes there is, and then we actually need to do that. All right, moving to the next example. Oh, I have my extra page here with nothing on it. Try the next one. Oh, here we go. All right, now I have a factor of 4. I have 4 on the bottom of this one and a 3 on the bottom here. Now 4 is really a 2 times a 2, and a 3 is just like 3. It's a prime number. So the only way that I can get my common denominator is if I take that 4 and times it by a 3, the 4 in the first fraction, times it by a 3 to make it into a 12, and I times the 3 on the denominator of the second fraction by a 4 to turn it into a 12. So what I'm trying to say here is the common denominator is 12 on this one. So we have 3 over 4, but we're going to times the top and the bottom here by 3 to turn that into a 12 on the bottom. And then we have take away, we've got 2 over 3, and that one needs to get multiplied by 4 on the top and the bottom to get a common denominator of 12. So 3 times 3 on the top is a 9 over 12. Take away, 2 times 4 is 8 over 12. Bottoms are the same, now I just subtract the tops. 9 take away 8 is 1/12. All right, so looking at the side-by-side example here, my x and my y, there's nothing the same here. So I'm going to take that first fraction, 3 over x, and I'm going to multiply the x by y. But I also have to do the same on the top to keep it an equivalent fraction. And then we take away 2 over y. But to get a common denominator, I'm going to times that y by the x. But then I also have to do the same thing to the top to keep it an equivalent fraction. That leaves me with a 3y over an xy. take away a 2x over an xy. So y times x and x times y are the same thing. Now, these top things, 3y take away 2x, those are not like terms. I cannot make them any simpler. I'm just going to write that as 3y minus 2x all divided by xy. That's as simple as we can get with that. Now, of course, there are restrictions with these questions on the variables, but I haven't focused on that for these particular questions. All right, now this is where we start to get a little bit more complicated. 15 and 10, I need a common denominator. Now, I could go just 15 times 10, and that would make 150, but that wouldn't be my lowest common denominator. It would still work, but not necessarily the best. All right, I'm going to look at 15. I'm just going to do some legwork down here. 15 really is 3 times 5, and 10 is really 2 times 5. So they both have a common factor of 5. So when I go to get my common denominator, it's going to be 5 times, and then this one has a factor of 3 that the other one doesn't have, so I need to pick that up. And this other, the 10, has a factor of 2 that the 15 didn't have. I need to pick that up. So 5 times 3 is 15, times 2 is 30. My common denominator would be 30 for this particular question. So to work with that then, I have my 4/15. I would need to multiply. If I look down here, the 15 was the 3 times 5. I have the extra 2 that the 10 had that the 15 didn't have. So I need to multiply by 2, top and bottom here. Okay, and this is laying our groundwork for our next example that follows. 7/10. So the 10, 7/10, had a 2 and a 5 already. The extra thing that was different was the 3. So we're going to need to times this by 3 and times this by 3. All right, equivalent fractions, we've got an 8 over 30 plus a 21 over 30. And 21 plus 8, I believe, is 29 over 30. All right, now how does this fit in with this question? Well, if I look at my 5t, so 5t, that really is 5 times t. And my other denominator was r times t, or an r and a t. If I look at how these compare, they both have t in common, so t is part of my common denominator, times, and then I have an extra factor of 5 on that first one, and on the second one, the r is an extra factor. So my common denominator for this, we usually put the constant out front, would be 5 times r times t, or t times r. And I just put that in alphabetical order. So that's the common denominator. If I look at the first fraction is 4 out of 5t, 4 over 5t. The part that's missing is the r. I'm going to times this by r on the top and the bottom. That's what's missing on that one, plus 7 over rt. If I look at my common denominator down here, the part that's missing is the 5, so I'm going to times this by 5, top and bottom. Now, we're almost ready to go here. 4 times r is 4r, and my bottom is 5rt, plus 7 times 5 is 35 over 5rt. Common denominators are in play now, so we're going to add our numerators together. 4r plus 35, can't combine anything, it's just going to be written as 4r plus 35, and we can do that as a single denominator of 5rt.